Today in this session we are going to learn how to express the concentration of various solutions. As we all know that solutions are made up of two components. First one is solute and solvent. Now, before we start anything else, we need to know what is the meaning of concentration. As we decided that solutions are made up of two components, one is solute and another one is solvent. So when we prepare a solution, we add some amount of solute to solvent. Now expressing that is known as concentration. How much amount of solute is added to how much amount of solvent. So that is the way we express the concentrations. Now there are various methods to express the concentration, various expressions for it. For example, we have mass percentage, volume percentage, then we have mole fraction, then molarity, molality, normality, formality, parts per million, that we say as ppm. So these are various types of expressions for the concentration. Now out of all these, today specially we are going to concentrate on the factor or the term molarity. So we will learn what is molarity and how do we express it. Now before we start with molarity, I would like to refresh your memories about mole. How do we calculate the number of moles N? We take the mass divided by the molecular mass or the molar mass. So if I have, for example, 32 grams of oxygen, then number of moles of oxygen N is equal to 32 by molecular mass of oxygen is also 32, so we get 1 mole of oxygen. So this is the way we calculate the number of moles. Now in molarity, as per the definition, molarity says that how many moles of solute dissolved in 1 liter of the solvent. Alright, so For this, we always need to know how to calculate the number of moles of the solute given. So the formula, we can write it this way. Molarity is generally denoted as capital M, that is equal to moles of solute divided by volume of solvent in liters. So this is the general formula we are going to use. Now there are some variations of this formula as well. So let's write the formula and let's derive its variations. So M is equal to number of moles of solute divided by volume of solvent in liters. Now let's take M as the mass of the solute and capital M as the molar mass or molecular mass of the solute. Then we are going to take 1 divided by capital V, that is volume of the solvent in liters. Now when we work with any numerical based on the molarity, it's always the volume of the solvent may not be given in liters. Sometimes the volume is also given in ml or centimeter cube. So if the solvent volume is given in ml or centimeter cube, then how do we find out the molarity? In those cases, one way is to convert the volume to liters and follow this formula, plug in the values in this formula, or there is another way. If you have this formula and you have the volume in ml or centimeter cube, you can multiply 1000 on top and you can do volume in ml. So this is also one of the working formulas that we can use. Over here, M is the mass of the solute, capital M molecular mass or molar mass of the solute, and V is the volume of solvent. In ml. So now we will remember this formula and let's work out some of the examples, at least one or two, so that we know how to use this formula to calculate the molarity. There is an example which says, calculate the molarity of a solution containing of a solution containing 5 grams of sodium hydroxide in 450 ml of solution. Now in this is a complete question. Now before we start answering it, First, what we should do, we should write down the given information in this question. So what are the information given to us? We have small m, which is the mass of the solute, that is 5 grams. Now we need the molecular mass or molar mass of sodium hydroxide. Now how do we calculate that? We know the atomic mass of sodium, that is 23, atomic mass of oxygen is 16, and atomic mass of hydrogen is 1. Now if you add all that, you will get 40. So 40 is the molecular mass of sodium hydroxide. So we have it, the gram molecular mass, that is 40. And then we need the volume of the solution or solvent, that is 450 ml. So here one thing, I can convert the 450 to liters and I can use it, or I can use the formula that we discussed, that is capital M is equal to, that is the molarity is equal to M by molecular mass of the solute into 1000 divided by volume in ml, volume of the solution in ml. So now we have M is equal to 5 grams divided by molecular mass of the solvent, that is 40, multiplied by 1000 divided by 450, which is the volume given to us. Now if you do the calculations, then we finally get the molarity is equal to 0.278, and we generally write like this. So the molarity of the solution, which is produced by dissolving 5 grams of sodium hydroxide in 450 ml of the solution, is 0.278 molar. So this is how we express the molarity. So this is the final answer. Now we can take a few more examples as well. Let's take another example in which they have taken 20 grams of sodium hydroxide in 482 centimeter cube of the solvent. Now over here, small m is equal to 20, molecular mass is equal to 40, because sodium hydroxide we have calculated, that was 40, and then volume is equal to 482 cc. Now molarity M by molecular mass into 1000 divided by volume in ml or cc. Now here 20 divided by 40 multiplied by 1000 divided by 482. Now the answer would be, if you do the calculations, then the molarity would come around 1.04, and we will write M over here. So that says the molarity of this solution, which is prepared by dissolving 20 grams of sodium hydroxide in 482 cc of water, is 1.04 molar. So I hope the concept of molarity is clear to all of you. Thank you.